Hi, my name is Ryan Verrett, and I'm a product manager at National Instruments for our NI FlexRIO product line. And today, I want to show you a demonstration of a prototype NI FlexRIO adapter module, which is based on a National Semiconductor high-speed analog to digital converter. This ADC either features two channels at 1.5 gigasamples per second with 8 bits of resolution, or a single channel at 3 gigasamples per second with 8 bits of resolution. And to demonstrate this, we've actually cabled it to our PXI Express 5450 arbitrary waveform generator, where we're generating pulses of variable width, and we're measuring those pulses with the high-speed analog to digital converter and actually performing trigger measurements on our FlexRIO FPGA. Let's go ahead and switch on over to the software to see a little bit more about this application.
So here you can see the actual software application. And the first thing I want to call your attention to is this graph of the non-interleaved channels, where we actually see two plots, one corresponding to each of the ADCs on the prototype adapter module. And these analog to digital converters are each sampling at 1.5 gigasamples per second, but they're 180 degrees out of phase for an effective sampling rate of 3 gigasamples per second. Next, we can see that we have a pulse width histogram, which basically is plotting the histogram of the pulse widths that we see coming in from our arbitrary waveform generator. So we see we have an average of about 620 nanoseconds, but that varies all the way from 500 up to about 700 nanoseconds. And then finally, at the top, we have an intensity graph, which displays all of the incoming pulses from our prototype adapter module. And here we can change the persistence as well as the intensity of the display to get an accurate representation of the data that's actually coming in. And what we're actually doing on the FPGA is acquiring pre-trigger samples, and then whenever we get a trigger or a rising edge, we send the data back to the host and a certain number of post-trigger samples. And that gives us a very tight alignment on this rising edge here, but it also allows us to see that we do have a varying fall time. And you can see in our persistence display a varying pulse width with a certain amount of ringing here when we return to 0. Anyway, that's about it for this application, but again, what we're showing off is the ability in the FPGA to do custom triggering, but then also with LabVIEW on the host as well, implement a full-featured pulse measurement application. Thank you very much.